Hello guys, welcome back to our YouTube channel. In this video, I would like to discuss about Bellman-Ford algorithm. It is a graph algorithm which is used to find the shortest path from the source vertex. See, uh, in this algorithm, they have given that given an weighted graph with V vertices and E edges, uh, uh, and then given a source vertex SRC. You need to find the shortest path from the source vertex to all the vertices in the graph, to all the vertices in the given graph. So, and also if the vertex is not reachable from the source vertex, then mark it as the distance is 10 power 8. So, and also given that note, if the given graph contains negative weight cycle, then return -1. First of all, I would like to discuss about this node. In this, what is negative edge cycle? Negative edge cycle means here they have given a example about the negative edge cycle. A negative edge cycle is a cycle in the graph whose sum of vertices is negative. If you traverse a cycle, the total weight accumulated could be less than 0. See, in this, uh, uh, keep in a point that see, if you start from a node 0, if and you travel cell around the graph and reach it to the same node 0, then the the weight should be equal to 0. It never be it it never be less than 0. But in this graph, if we travel from 0 to 1, the weight is 5. And if you travels from 0 to 2, that means 0 to 1 and then 1 to 2, then the total weight is 5 plus -1. So the total weight is 4. And then if you travels from 0 to 0 itself, it means 0 to 1 and then 1 to 2 and then 2 to 0, then the total weight is 5 plus -1 plus -5. It is -1. But we know that in any graph, the weight from the given node to itself is 0. But in this we got -1. So it is a negative weight cycle. So for these type of graphs, we should return the value of -1. I think you understand, right? Next, okay, let's go into the question. See, for the sample example 1, they have given 5 vertices 0, 1, 2, 3, 4 and the edges. That means the edge and the edges with their weights. That means 0 to 1 there is an edge with the weight of 5 and 1 to 3 there is an edge with the weight of 2 and then 1 to 2 there is an edge with the weight of 1. Make a note that all these edges are directional edges. See, you have seen that here there is a direction. Next, and the given source index is 0, source node is 0. So we need to find the shortest path from the source node to remaining all the nodes in the given graph. So let's take this example and write down. So initially we do we keep it as the shortest path from source node to remaining all another nodes is 10 power 8. 10 power 8. 0 to 1 and then 0 to 2, it is also be 10 power 8 and then 0 to 3, 0 to 3, the shortest path is 10 power 8 and then 0 to 4, the shortest path is 10 power 8 and also 0 to okay, only 0 only 4. It means given that there are 5 edges, so that 0 1 2 3 4. So here is the now the algorithm part is given that the source vertex is 0. So what are the nodes which are directly connected to the source node? 1. See, 0 to 1, it is directly connected. So the weight from the 0 to 1 is 5, which is definitely less than 10 power 8. 10 power 8. So we update the value here. We update it to 5, and then and then uh, and then we move to the node 1, vertex 1. So now so again repeat the process. What are the vertices that are directly reachable from the node 1, from the vertex 1? That is vertex 3 and the vertex 2. So here uh, for 3 for the vertex here, for the vertex 1, and now for the vertex 3, what is the uh, path is 5 plus 2, this 5 and plus 2, 5 plus 2 equal to 7, and it is also definitely less than 10 power 8. So we update the value 0 to 3, which is 7. 0 to 3 means 0 to 1 there is 5. The weight from the 0 to 1 is 5, and then 1 to 3 is 2. So sum is 7. So 7 is definitely less than 10 power 8. So we update the value. Then uh, uh, we have completed 1 to 3. So now we are doing 1 to 2. So for the second vertex, 5 plus 1. 5 means 0 to 1 the weight is 5, and then 1 to 2 the weight is 1. So which is equal to 6. It is definitely less than 10 power 8. So we update the value here. 0 to 2, till now our shortest path from 0 to 2 is 6, and then from 3 uh, they, there are no another nodes from 3. So then from 2 there is a direct node from 2, which is 4. We can directly reach from 2 to 4. So for the fourth node, which is 0 to 1, the path, the weight is 5, and then 1 to 2 the weight is 1, and plus, and then 2 to 4 the weight is 1, which is equal to 7, and it is also definitely less than 10 power 8. So we update the value here. 0 to 4 the shortest path is 7. Then from the fourth node we can reach to node vertex 3. So again for the vertex 3 the path is 5 plus 5 means 0 to 1 5, and then 1 to 2 it is 1, and then 2 to 4 it is 1, plus 4 to 3 it is minus 1, which is equal to 6, and it is less than the what is the value here? We have 7, which is less than 7. So we update the value 0 to 3, it is 6. That's it. We have completed the algorithm. So as we seen that the output also output here in the output the first element indicates 0, because the vertex from the source node to itself, which is 0. It means 0 to 0. means 0 to 0. The weight is 0 now itself. So now if we consider the second example, so in this in the any example, in the any given graph, first we need to find the cycle. If cycle means if there is any negative weight in the given cycle. So uh, for the given exam, for the input one, there is no cycle. You can all you can once recheck it. From the from the example one, there is no cycle in it. So we directly we directly step into the problem. But in the example 2, there is a cycle. We clearly observe that there is a cycle from 1 to 2, and then 2 to 3, and then 3 to 1. There is a cycle. So if we found a cycle, then we need to check if it is a negative weight cycle or not. So if we consider 1 to 2, the weight is 6. Okay. Then 1 to 3, the weight is minus 6 plus 5. It is minus 1. It is also fine. Then now the weight from 1 to 1 itself, that is 1, the path will be 1 to 2, 2 to 3, and then 3 to 1. Here um, here the total weight is, it is less than 0. It is minus 3. It is impossible. So given, so we return the output here as minus 1. As we see in the explanation, they given that the graph contains negative weight cycle. As simple as that. And you can also check it the code. It is also a very straightforward code. Initially, and then time complexities. In this, the best case. In the best case, the time complexity is big of E. Here, E means total number of edges in the given graph. When the distance array after the first and the second relaxations are same. Relaxation means total number of iterations. Here, relaxations means total number of iterations. We can simply stop further processing. It is in the best case. Now, but when coming to the average case, which is number of vertices into number of edges, it means we cover all the vertices and all the edges. And the time complexities for the in this the time complexities for the average case and the worst case are same, because in the both the cases we travels all the vertices for all the edges. And that's it, guys. Thank you for watching. Please do support. Please like, share, and subscribe to my YouTube channel for the more informative content. If you have any doubts, please comment down in the comment section. Thank you.